to do the right thing, you know. So we have this 20, what? It's 2016. What? Yo, I didn't take a good enough screenshots. I did is leave out the other stuff. But anyways, let me just paste this here, and then we shall begin. Begins is
The witchcraft has started.
that word again. Yo, it keeps coming out of your mouth, ma'am. Why are you not telling us? You want to confess?
What am I not telling you?
This is the wrong place to
I don't
do so,
do
ma'am.
confessionals.
This is not confessions KZN. It's not that. That is fine.
You took it there.
Yeah, there's a place and time for all that. But anyways, it says here in the diagram.
Yes.
Let's see what we can do here. In the diagram, right? M is the center of the circle. There we go. And then it says here it is a circle passing through T, R, and S. So there's a law that says that if a line is a diameter of a circle, so we know that this is a diameter of a circle because it's a straight line passing through the center. So it's a diameter of a circle automatically. Now, because it's a diameter of a circle, what we also know is that this is 90 degrees. That's a law. An angle that is subtended by the diameter of a circle is always a 90-degree angle. But this line has to be cutting through the center. So it says here.
Can I just, whenever you say something is subtended, the English flies over my head.
Okay, so what I mean is, you see, like, think of this as like a rope. You see, it's like tied here, right? And then it's like stretched towards R and it's stretched towards T. You see, think of like a rope. If you have a rope, right, and you hold it here, and you pull this towards one side, and you pull this towards one side, you're gonna have something like this, right?
Yeah.
Yeah. So yeah, so that's what we mean by an angle is subtended by something, because whatever angle is formed here, right, there will always be something down here. So this angle is subtended by this line. You see? So we can say angle C is subtended by line AB. You see it? Does it make sense?
Yes, I see it.
Yeah. So with our sketch, right, what we have is angle S here. It's being subtended by TR. You see? So there's S here, there's a line going to R, line going to T. So with that being said, the rest of the question says K, which is AB. So there's K way now. K down here, right? It's A coordinate B. It is a point in the fourth quadrant. So you have quadrant number 1, 2, 3, and 4. So it's always anti-clockwise, starting from here. 1, 2, 3, 4. So fourth quadrant is down here. Yes, ma'am. Yes, ma'am. 100%. 100%.
Yes.
120,000 all day, every day. Anyways, what else now? It says here, it's in the fourth quadrant such that KTL, where's KTL? K, T, and L is a tangent. So if this line is a tangent, what does it mean now? If it's a tangent, we have to remember something very important. It's another Euclidean geometry law.
Yes.
Yeah, it's another law. Now there's a law that says that any line that's the radius of a circle will always meet a tangent at an angle of 90 degrees. It's a law. We just need to keep it in mind.
So literally the point of contact, I should consider it also 90 degrees.
Yes.
Okay.
As long as this is a radius or a diameter, and as long as this is a tangent, they'll always meet at an angle of 90 degrees.
Let me just write that down quickly.
Yeah, sure. The other thing is there's a lot here that we're saying that will be re-said when we will start with Euclidean geometry, like literally. You know, it's just one of those things, really. But you'll see what I mean when we will start, because all of this will come back. So
Okay.
they said here for 1 mark, give a reason why TSR is a 90-degree angle. So what we said in the beginning is what we need to say here. This angle is 90 degrees because
Okay.
we can say one of two things, you know, they are both correct ways to say it. The first thing we can say is that we can just say it's, let's say here TSR is an angle in a semicircle. That's one way of saying what we mentioned in the beginning. Because you see that anytime you have this angle being 90 degrees, right, you will always be having half a circle, and then that angle will be inside half of that circle, because it will always be subtended by the diameter. Remember, the diameter literally cuts the circle in half. So you can see here where you have half this circle, you have an angle inside half the circle. See? So that's one thing you can say. You could have also said, oh, angle subtended by the diameter of a circle. You see it? Angle subtended by
I
the
used to
diameter.
wonder where the semicircle was. Now that you've explained it, I see it now.
Nice, nice, nice. We love to see it, ma'am. We love to see it. We love to see it. What else? So, with this being said, right? Let's see what the next question is asking us to do with our brain. Let us see what we should do next. I'm gonna crop this out. Do this. Do that. They're asking for the gradient of TS. Wait, TS. TS is this line here. TS. So I mean, like, the run is quite straightforward, right?
Yeah, they've got two coordinates on there, so.
Yeah. So as long as we have two coordinates, we can do what?
Just plug it into the gradient equation.
Yes, I know. I just had to say it. I just had to.
I said it though.
It's just one of those things, you know. It's just one of those things. It's a bit awkward when you have to say things that are obvious. It's like, ish, I'm sorry, ma'am. I'm sorry, but we just have to say it. So the gradient of TS is just y2 minus y1, x2 minus x1. And then it says here, what? 7 minus 2, we can do that. 7 minus 2, and then 3 minus 5. 3 minus 5, right? And then it's like minus 5 here. No, positive 5, bro. Positive 5. Positive 5.
Look at minus.
It was a mistake, madam. It was a mistake.
Oh.
Forgiveness, please. Apologies.
Okay.
Thank you. We thank you for your generosity. The resistance will forever remember your
There's a
kindness.
resistance. Jeez. This is getting out of hand. I love it though.
Yeah, I know. I know, ma'am. I know. The resistance is getting stronger every day. I need to, when we finally get what we want, we already know who's going to be the president. I thought you knew. I thought you knew.
Ew, I didn't know. She can't be president.
It's too late, ma'am. We have already voted.
She's not gonna run the country.
It's too late, madam.
She will not run the country. She's on one food only. Know her. Am I wrong? Did I lie?
Sam, don't worry, madam. We'll find something for you. It says here, the next question is out of 3. It's out of 3, right? They want us to get the equation of SR. So yeah, so you see SR, what can we do to get the equation of SR? Because remember, we just need a gradient and a y-intercept. So what can we do?
Can I see the full question from the beginning? Just want to see if there's like any information that I didn't recall.
Yeah.
Yes.
Yeah. Let's see. So probe Let me just bring this picture closer then, so that you can see it
Wait,
until your
Jesus
heart
Christ.
is content.
Also, your clothes.
So this is a 90-degree angle. Don't forget. They want us to get the gradient, the equation of SR. And then remember, we always said, always think of the questions they would have asked us beforehand. So don't forget them. Like here, we worked out the gradient of TS. And then the previous question, whatever, we got this as a 90-degree angle. So how do you think that's useful for us to get this and the equation of this line here? How are the two previous questions really trying to tell us what we should do for SR? Because remember, it's two questions we should answer, because we know that this is the equation we are going to use to help us. And we all know that in this equation, we just need two things. We need a gradient and we need a coordinate. We already have a coordinate. Yeah, we already have a coordinate. That's sorted. But then now, where do we get the gradient of SR now?
Oh, we could use previous gradient because they're also on the same line. Yes.
Well, I think what you're trying to say is the previous gradient, the line is perpendicular to SR. So what we know about perpendicular lines is that their gradients
equals to minus 1 linear multiplied.
Yes, look at you. I'm going to make you the Minister of Education. So don't blame us. Don't blame us. Don't blame us when that happens, because it's not our fault. We are just trying to do the morally correct thing. So anyways, the gradient of SR, we will get it using this formula. So the gradient of TS, we got it as negative 5/2. So if you divide by negative 5/2 on both sides, what are you gonna have now? Negative 5/2 on both sides. Let's see here. This cancels that. It's like, yeah, MSR is equal to 2/5.
2/5. Yeah.
Perfect. So you can see how, remembering that with gradient, there's many things. We don't have the two coordinates of SR, but we have a line that we have a gradient for. So that's the easiest thing to do. Like the previous questions, it's almost like a map. You know, that's how some of these questions, it almost feels like you're cheating when you're just answering them, because it's like, guys, you gave me the answer in the previous question. You just literally told me what to use. So let's see here. In the equation here, we're gonna have y. S is what? S is 5 and 2. This is like -2. And then the x value there is a 5. Yep, is a 5. And then let's see here, 2/5x negative 2. And then y -2. And here, everything on one side except for y, you're gonna have 2/5x. -2 plus 2 is gonna give you a 0. Yeah, it does look a bit accurate. It does look like it's going. This kind of looks shady. Oh, maybe it's just not to scale. But no. This is a 5. It's a 5. It's a 5. It's a 5. I wrote the wrong number. Yeah. The answer looked a bit shady there. -3. Because I was trying to look where this line is going to, and I was like, what? How can it have a y-intercept of 0? It didn't make sense, because this clearly is going down, and you know. So even though it's not to scale, I mean, like, it has to at least make some kind of sense, you know, because I mean, one or the other, it also does kind of look to scale. So
yeah,
I might as well use it as such. So that's that for this question, right?
yes.
Nice. So let us see what we have to do here. Karopa, just open for there.
Oh.
So they say we should get the equation of the circle. No, they say they're giving us the equation of the circle. So they say the equation of the circle above is this. This is telling us the x value of the center, which is positive 9, and then the y value of the center, which is positive 3, positive 6.5. Because you always take the opposite of what you see here for your coordinates of your center. So remember this
Also
format,
opposites. Okay.
yeah, always and forever. Because remember the equation of a circle, the format is x and then negative a squared and then plus y minus negative b squared and then r squared,
Will the
right?
same apply for the radius as well, or is it just for the ones in the brackets?
Now, this number here is it's standing in the place of r squared. So we have to be careful. What we know is that r squared is this number, the whole thing, you see, 36.25.
No, I'm saying taking the opposite sign. Will that also
Oh,
apply
no,
for the
no,
radius?
remember the radius is a distance. So you always take the number as it is. So this distance here, you can see it's a length, it's a distance. Distance is always a positive number. This one you always take it as it is.
Okay.
Like remember, this is not the radius. This is where r squared would go. You see here where a is, you have a 9 there. Where the b is, you have 6.5 there. So this is telling you that remember a coordinate b will always be the center. You see, and then this r is the radius. However, you see here, this is not the number squared. The number here is not squared. So you cannot say 36.25 is r. Where this whole thing is, that's where the whole of r squared would go. So r squared is 36.25. Meaning if you want the radius, it's just going to be square root this side, square root this side. And then this in our calculator, we have to be very careful. When you put this in your calculator, don't just press the fraction button and put 36 in front.
Fraction.
You have to make it a mixed fraction, meaning you have to press shift and then the fraction button. And then you can put those three numbers in those three slots that come out in your calculator. So that's what you need to do.
Complicated.
No.
I'm saying the answer.
Oh, what did we get? Is it like where we can? Is this?
It says square roots of 145 divided by 2.
Yeah. So that's how is that complicated now, Meta?
It's messy to look at. No, I don't like it.
I mean that's the thing. I understand. I get you. Everyone hates SERDs until they see that they give the marks, and it's like, okay, I guess there's no need to be hating something that works for you. You know, just don't hate it. You know, it doesn't benefit you really. You know, it's just something normal. It just wants to be treated equally. You know. But anyways, coincidentally here for 2 marks, they said we should calculate the length of TR in said form. Where's TR? You see that TR is the diameter.
Yes.
Yeah. And remember the diameter. Yeah, the diameter is always double the radius. You know, one radius, another radius length. And we already said we know what the radius is. The radius is this number. You see. So TR 4.4.1. Let me see here. 4.4.1 is giving us square root of 145 over 2 times 2, because it's a radius doubled, of which this is going to give you just square root of 145, like that.
Oh.
Yeah, that's what TR is. TR is just the radius doubled, because that's what we need to take into account. TR is the diameter of the circle. Is that fine?
Yeah, that's fine.
Perfect. I got it. Perfect. So let's see here. 4.4.2. Let's see. 4.4.2. What is 4.4.2 now? Crop. 3 marks. So this is out of 3. 3-mark question. And we have to see what we shall do.
I knew it.
Yeah, so they want us to get the coordinates of R. So wait, how many marks? Out of 3. So this one, let's keep calm. Let's not try and overcomplicate anything. We have a point here. It's somewhere in a random location. And remember, let's put hints as many as we can. Remember, they gave us the center here. So this is like 9 and 6.5.
The midpoint.
Ah, look at that. Would you look at that? So do you see? We didn't have to even do anything because everything is given. But then the thing is, as long as we always stay too focused on the question and not focused on what they have actually given us, we'll always struggle. Like here, if let's say us not knowing that this is R squared, this question would have been difficult. If we did not know that this represents the center, this question would have also been difficult, So this is to show that everything is literally a map. Anything they give you is supposed to help you work out what they have asked. And we're seeing it here in practice, you see. And as you say it here, we're just going to use the midpoint formula because we can see that M is in the middle of T and R. So we know that 9 is the X value of the midpoint. So we know that 9 is equal to X1 plus X2 over 2. We know that 6.5 is the Y value of the midpoint. So Y1 plus Y2 over 2 is equal to this, of which we know what T is. T is 3 and 7. See, so there's 3 there, 7 there. So we're going to have here 9 is equal to 3 plus X2 over 2. 6.5 here is equal to 7 plus Y2 over 2. And then we need to solve for the two values, you see. So times by 2 here, times by 2. This is like 3 plus that. And this is like 15. Here,
15.
6.5 times 2. We have to be careful in the calculator, you see. Shift fraction button. Then we put 6.5 there. Multiply that by 2. That's going to give us a 13. A whopping 13. So we're timing by 2 here, times it by 2 there. Zoop. Oh, nice. Look at you. So ahead, so advanced. 2022 model. That is dumb. Let's see. What is R?
Actually, I like that.
Pardon? Oh, how many days?
I actually like that.
Nice. You should put a price tag on you. Never mind. Forget that last part. Forget that last part. There's 16 here. No, 15 and 6. So yeah, it kind of looks accurate because it's 9 is definitely after. 15 is definitely after 9. And then the Y value though, what's the Y value? It's a 6. Yeah, 6 is below 6.5. So that makes sense. That's the Y value. So yeah, any chance you get to check your answers, don't take it for granted. Checking your answers is priceless. It's one of those things that is not done, but out of excitement, people just move on, and then it's like, yep, you lost marks. You could have had a lot of marks, but no, you just wanted to be fancy. Now you're crying.
I don't think it's like excitement. It's like I'm gonna check the thing. What if it's wrong? It's like I'm gonna sit here and then re-worry and rework, and then
No, that's how you make sure you don't have to re-worry. Because whether you think so, if you don't check stuff, right? Normally, what happens is subconsciously you're still thinking about it. You just want to be certain. The more certain you are, the better for yourself during the exam, because the more comfortable you are, for other questions as well. So yeah, that is very important, ma'am. It's very important. Let's just check. It's just like what was I saying that day? Just like driving. Driving is all about double checking everything. That's all it is, really. It has nothing to do with everything else. So anyways, we have r, the coordinate, but now they want us to get r, the angle, for 3 marks also. So remember, don't forget how we have all these coordinates here. So we have these coordinates here. What can we do to get angle r?
I mean, I guess if you look at the gradient for the, I suppose you could work out the gradient for it if you needed to have TR.
Well, don't
And then
overthink
use
it. Like don't overthink it. Because it's a 3-mark question and we have a right angle triangle here.
I don't understand why.
You see? But then, so if you think of trigonometry, what can we do with this right angle triangle to get this?
Don't ask me about trig. I feel that section hard.
I don't know, Madam. We are here to make things okay. But anyways, we have a right angle triangle here. Now, the fortunate thing is we also have this length of TR. TR is square root of 145. And we need an angle. Well, no, Pythagoras gives us the lengths. If we had like 2 sides and we needed a third one, we can use Pythagoras. But so far, we should think of things like normal trigonometry, like so. Yes, like opposite over hypotenuse, adjacent over hypotenuse.
Adjacent over hypotenuse.
Yeah, and then opposite over adjacent. You see. So that's what we should be. That's what we should be thinking of. You get? Yeah. So let's just quickly do this question, and then we shall see what we need to do now. Oh yeah, so it looks like for this question, since we already have the hypotenuse here, right, we might as well just get any other length for us to eventually get this angle. What I mean is, if we have TS, right, if we have the distance of TS, then we will have what is this? We will have, if we need this angle here, right, and we have square root of 145 here, if we at least have this distance of TS, we will at least have the opposite and the hypotenuse. So if we have the opposite and the hypotenuse, we can get this angle, because sine r, what are they asking? Calculate sine r, right? Remember, sine r is opposite over hypotenuse. The opposite is TS, the hypotenuse is TR. You see? So we need TS and TR. Yeah, TR we have, so TS, what can we do to get TS? The length of TS.
Yes. Distance formula.
Yeah, definitely. The distance formula. We can just use the distance formula. So that's what we're gonna do. So let's do it. What do we need here? Let me see there. Come on now, come on. So the distance formula, it doesn't matter what we put there. Let me just put TS here. TS is going to be like 7 minus 2 squared, and then 3 minus 5 squared. And then it's like 5 squared. 3 minus 5 is what? Negative 2 squared. Yo, I don't even know I'm doing this with my head and not the calculator. Yeah.
Because you're sharp like that. We like you like that.
No, that's being reckless, man. That's being reckless. It's like driving without a seatbelt. You're like, you're a star. You think you're a star until you're dead. So let's see. This is square root of 29. And then what is TR? TR is like square root of 145. So that's going to be the answer. You can put it in your calculator. It will give you, let's see if it has a simplified version of that. Square root of 29, square root of 145. Yeah, it's square root of 5 over 5. This is the answer. Cool.
Coolio.
yeah, let me stop with this one for now. So